All right, so with logarithms, probably one of the most important pieces is natural logarithms. So on the calculator, you've got log, you also have ln. Now, this is natural log. I don't know why it's backwards, but it just is. So log is base 10 and ln is base e. Like if you look on top of log, it says 10 to the x. You look on top of ln, it says e to the x. These are inverse functions. That's why when you do ln e to the x, it equals x because the bases match. E raised to the ln, the bases match. Everything equals x. So they have to be totally next to each other, though. Nothing can be in between. As soon as the bases match, ln e cancels. It's just 3. Now here, the square root's in between, so you have to rewrite it. The square root, written as an exponent, is 1/2. So as soon as you change it to the 1/2 exponent, the ln e cancels, and it's 1/2. There's a 2 in between. I'm going to rewrite this a little bigger. I can't cancel the e and the ln because the 2 is in between, so I have to move it back to being an exponent, the logarithm rule property. So this is actually e to the ln 5 squared is 25. As soon as nothing is in between e and ln, whatever's left is your answer. All right, so this is that goofy thing again. We take 50 equals e to the ln 50. And if you take e to the ln 50, you keep the e, type ln 50 in your calculator, and it's 3.9, oops, dyslexic here, 91. Same thing here, 0.05 equals e to the ln of 0.05. Plug ln of 0.005 in your calculator, and you get negative 5.30 if you go 3 sig figs. To me, this is kind of pointless, but maybe they'll use it later. I don't know. Okay. You'll notice the laws or properties are exactly the same. Whether it's log or ln, when you add the logarithms, I think the big thing when you see ln, you have to understand they're still logarithms. They have they're same thing. So when you add, you're going to multiply. If you log or subtract the logs, you divide the bases, and anything being multiplied can move back to being a power, or anything that's a power can be moved back to being multiplied. All right. So if we want to solve for x, in order to cancel ln to get x by itself, I'm going to e both sides. Just like you can add 2 to both sides, divide by 2 on both sides, you can e both sides because e cancels ln, and you get e raised to the 2.17. Then if you plug this into your calculator, it's really approximately 8.76. Same thing here. In order to get x by itself, we need to get rid of ln. The inverse of ln is e, so we e both sides. E to the negative 0.384. Plug this into your calculator, and it's approximately 0.681. Now we're just going to condense using our laws of logarithms. And the good news is I think this stuff's all in your formula booklet, so you'll have them available if you forget, but they both have ln, and since we're adding ln, we can condense into one single ln, and when you add the logarithms, you multiply the numbers. Here they each have ln, so we can condense into one ln. Since I'm subtracting the logs, I divide the numbers. All right, this one doesn't have ln for both, so the first thing you're going to need to do is change this. So 1 equals ln of what? Ln of e to the first. We're making both of these ln. That means we have to match the bases, and this is the exponent. As soon as I do that, I can condense into a single ln. And since I'm subtracting my logs, I divide my numbers. All right. Now, we can't condense if there's anything in the front. So the first step is always to move anything in the front back to being an exponent. And then I'm going to simplify each of these. 7 squared and 2 to the third. Now, as soon as everything's basic, I'm subtracting my logs so I can condense into a single log and divide the numbers. All right, so I've got to do 2 things to get ready to condense here. First, I need to move this back to being an exponent. Since this is ln, I'm changing 3 into ln of e to the third. I want this to be an ln. That's why I'm ln of what equals 3, ln of e to the third. All right, 3 squared is 9. Now I condense from 2 separate logs into a single log, 9e to the third. And I think that's it. Yep. I think it's probably going to be helpful for you guys when you come across your theory of knowledge, and it will help your theory of knowledge class later to have kind of an exposure in all of your classes. A lot of times with math, we talk about, is it invented or discovered? This says the logarithm was invented by John Napier. But were they always there? And is it just discovering something that was actually there? What is it? How is the knowledge? Just kind of read through and think about it. Okay.